Hi everyone, so today we will see how to work with AI and hardware. Everyone is talking about coding with AI, copilots, agents, cloud code, but much less attention goes to system administration and networking work. Managing bare metal, using BMC interfaces, working with switches, routers is still manual and disconnected from AR workflows. I wanted to explore this gap, which is much less covered in all other videos. What if AI agents could operate real infrastructure, like powering booting servers from images, inspect hardware, query and configure switches, not just writing code? And this is exactly what this project is about that I wrote recently. Today we'll go through a few practical use cases, working with AI agent to query servers, perform operations like updating firmware, adjusting configurations, and other fun. So stay tuned. So first let's install this MCP server. It's located on my GitHub, SSH9 bare metal MCP. And installation is very short and easy. It takes about 20 seconds maximum. So firstly, we'll need to clone this repository. We are cloning cd to repository and installing all required requirements. After this, we'll go and see what exactly we would like to install for which agent. For example, for Cloud Code, it's just two commands, very easy. Cloud plugin marketplace add. And the second one, Cloud plugin install. And that's it, easy peasy. For Gemini CLI, for example, it will be just one command. Gemini extension install and link to the repository. Let's do it. And we install in Gemini as well. Cool. Now we need to configure actual servers that we will work on, right? So first we need to configure Redfish servers YAML file, which will hold all servers we have. Second one, secrets for the servers for BMC. ISOs and global config is optional. So for example, my servers list looks like that. You can see here server sections, labs if you want. And the mandatory is BMC IP. That's actually BMC IP that MCP server will communicate with. Tags are optional but very recommended. For example, if you want to filter your hosts by geographic location, vendor, some features, and so on, it will be very useful to have. For example, update the host that located in Dallas, for example, like that. And in the end, you can see even switches. What about passwords? It's just related to the host ID that we saw in the previous file. And it can be any password that you use for BMC, for switches, and so on. So this is two files actually that should be configured for working. And after you configure them, let's move the next step. Export actual environment variable that will point to these files. For example, export redfish config will point to redfish servers, and export redfish secrets will point to secrets file. After you set these environment variables, you are ready to go. ISOs file, for example, let's see the ISOs file in the bare metal repo. Here, for example, I hold all firmware files that I serve from local web server to update firmware for BIOS, for iDRAC, or for anything else, for NICs, for example. This is optional. If you need to update firmware from local files, it's quite useful to have it. And finally, global config. Just config for MCP servers, timeout, cache, and so on. And for example, when we run with Gemini CLI, we can just check this MCP list. And if you see bare metal MCP in green, then you are all set. And for Cloud, you just run MCP list as well. And if you see bare metal MCP connected, then you are all set as well. And for any other installation like Cursor or anything else, you can just check the README. You will see here configurations. And for generic AI agents, link to this repo will be in the description of the video. And let's start working on the live servers that I have in my lab, and let's try some use cases. Let's go. Alright, so right now we'll start from retrieving some information from our lab about hosts, and we'll start from something very easy to do, like listing BMC and BIOS version for hosts. Boom. And currently it's connected to our Redfish MCP server, fetching the host list from Redfish server's YAML file that we created before. Right now we have 27 of them, and it's finished quite quickly. And it has also, okay, it's broke down by groups of servers versions, and that's great. Okay, it showed even about power and health, which I didn't request actually, but great to have them. All right, cool. It even overperformed. Now let's try something more complicated. For example, I would like to see memory slots, calculate how much memory we have in total for hosts, and I would like also to see how many free slots for memory we have, and in future, so we can consider update. Well, right now memory update probably is not the best decision. But anyway, I'm recording this in 2026. And let's do it for hosts, specific hosts. Let's not do crazy things. Host 7 and host 15. Boom. Here we actually have parallel redfish call. Yeah, exactly. That's what it's gonna do. But of course, Cloud Code can parallelize by itself, just running sub agents. But probably it's better to use parallel redfish call from Python. It will take less resources than running sub agent for every host, especially when it's hundred of hosts. And hundred of web requests, for example, is not so many, not so big load. Okay, it was quite quick as well. Currently we have information for every host, and let's just see the summary. In host 4, okay, roll the model, slots total, taken, and free. It seems like everything is taken here, which is probably not the best, but let's see different host and how we can upgrade it. Okay, I would like to see memory in host 100. Slots in hosts. Okay, this is HP host. So this MCP server works with Dell, HP, Supermicro actually, and probably all other hosts, but Supermicro should be tested better. Dell HP works for sure. Alright, so we see the results coming. It requested actually info for every slot separately. That's why it took so much time. And okay, so one have taken half of slots and the second as well. Okay, maybe it can check for us something like finding memory and how much will cost to upgrade this host, for example. Let's check only one host, 101, and what can we add there, and later might be we will find also price for this. So in host 101 we have 32 slots in total, taken 16, and in total it's 256. So let's see how we can upgrade to 512 probably. Alright, so it suggests to fill remaining 8 slots, which is totally logical and great. And now let's try to see how much will it cost. Okay. Estimate the upgrade cost for now. Okay, we see results coming. And yeah, it's quite not cheap. Aftermarket is fine. And recommendation and total prices. Alright, guessing that it checked actually prices for specific memory that we have on the host, not just random memory to keep everything in sync. Alright, now I would like to see something about networking here. And let's say we are going to prepare some network cards replacements and upgrades. I would like to see what is state for these servers and for slots for network cards, which of them have network cards and how many and which ones, and which servers I can put another network card, for example. We can see that it saves results in file because it's too big output from Dells. Okay, this is the information that we requested. So let's see what we have here. This is all statistics about network card slots. And in total, we can see that servers with 3 NIC slots. Every server has actually 3 slots. That's great. And total slots in all servers 62. And we have breakdown by slots, kinds of them. And that's great. Let's see some server, for example. 16, 8 lanes, half lanes, hot plug no. Alright. About full lanes we have in different hosts. Alright, and full length. So that's exactly what I wanted to know about full length and and half length. So we can know which host can contain which cards. Right now everything is going okay, and let's see some disks. For example, for servers, host 10, host 12, 17, host 102. Just to make some different calls for Dell and HP to make it a little bit complex. So we checked for now memories, network cards, and now let's see disks. Alright, I see information is coming. It took about 1 minute to get it. And we can see all disks about and their capacity, even a life left. Alright. Some of them have only 99% of life left. Interface, health protocols, and everything we can use for having information about total space. And probably now let's see some security stuff. And we'll see servers without read-only users. Let's see that we have good practice by having some read-only user for BMC. And let's see which servers don't have this. Because some of them are quite new, I believe it will be not one server. Okay, I see information is coming. And yeah, okay, we see that 9 servers have no read-only user. Okay, and that's for us to fix. Awesome, great. Now I would like to continue with networking probably. And I would like to see total bandwidth, for example, for hosts with all connected interface and ports. And to show also vendor of network cards that we have. Let's do it for hosts from 10 to 20 and 101. Okay, this is information that's coming. And we have adapters, vendors, and model. How many ports connected and speed and also bandwidth in total. It also broke down this by a model of hosts, which I again didn't ask, but thanks, Claude, thanks. And in total, we have bandwidth table for every host and all network cards that we have on the hosts. But now I would like it to do something very smart. Not query just for hosts, but do some more work. And we will start checking this for OpenShift installations. For example, I put here a link for bare metal requirements for installing OpenShift. It includes various Dells and HP versions. And just to show you how it looks like that. For every generation, it has a BMC version and which firmware version actually supported for OpenShift. And I would like Claude actually to take our lab, all our hosts, and to check whether they comply with this requirement. And if not, what should we do for making this host actually to be compliant with this. So let's run this request and we'll see what should we do for making hosts actually to be compliant with prerequisite for bare metal installation. Okay, I see some info is coming. It took quite a long time, mostly because it couldn't fetch the PDF that we saw before. I don't know why. Just recently I tried the same and it was fetching this PDF quite well. Probably that's the reason. Alright, this is the table that actually I was looking for. What exactly should we do? And yeah, it started to look for sources in GitHub and in Google. Okay, probably I will just try to copy paste it and let's see if it makes it better. So let's take all these requirements, copy paste, and put it here. Requirements for 421 are those. Let's help it and see if it really helps. All right, we see some answer. Cool. So we can see what exactly is different from these requirements. So firmware a little bit different, required just 30 instead of zeros. And okay, it's small upgrades that we need to do, and we'll do it just now. Stay tuned. And not in matrix. Okay, now. Right, so what we have here more? Non-compliant stuff, non-compliant, advisory, boot orders, a lot of stuff, and fully compliant 5, iDRAC firmware to all 22, so it's minor upgrades, not in the matrix one host, and boot order fix needed and firmware. Great. All the stuff we will do just in a second. And all right, that looks pretty cool. We retrieved information about networks, disks, memories, about hosts themselves, bandwidth, and whatever not. And you can do it on actually any network, any set of hosts that you might just, investigate for any hardware upgrade or anything else. Quite useful tool, I would say. Okay, so right now I would like to do what we did here in Cloud Code, but in Gemini CLI. Gemini CLI is agent based on Gemini, and it's quite similar to Cloud Code, but it has some advantages, to be honest. Maybe not for code, but mostly for tasks, sub-agents, working with terminal, and so on. But this is a topic for a different video. So right now I would like to do the same checking prerequisites for OCP installations. I will give it the same document, the same link, and we'll see how it processes. And we'll choose hosts from 10 to 15, and let's start and see what we see. Right now it should check hosts, 5 hosts, whether they are ready for OpenShift installation, and if not, what we should improve there, install, upgrade, and so on. Okay, I see some results arrived, and it checked 5 hosts, actually 6 hosts, sorry. And with table, what is compliant and non-compliant? That's great. Let's ask the question, what should be done to make these hosts compliant? Okay, seems like it started to work actually on the host. And for host 10, it update BIOS. All right. And some alerts about temperature. Okay, that's information that might be useful. And it's great that I actually parsed the logs and discovered alerts and detected that we need to clear and fix some things before installation. That's awesome. I didn't actually ask, so it overperformed here. And let's see if it really does the things. Yeah, so we can see here that right now it scheduled the update of BIOS. It will be rebooted and then updated. And okay, so let's reboot the host for BIOS update. Alright, so it's rebooted. And we can see here that reboot pending, so it will be updated very soon. Awesome. Alright, let's do this for next bunch of hosts from 16 to 19. Alright, so we have a table of results. Quite iDRAC versions looks fine. So it suggests to execute firmware update on hosts. And let's do this firmware update in bulk. So right now I will do upgrade of firmware on live hosts, kind of scary. And let's pray that it will finish fine. Update iDRAC firmware on these hosts. Let's start from hosts from 15 to 19. Let's do 5 hosts first. Okay, it found the ISOs file that actually is required for updating. This is the file that you host all images with upgrades from Dell for BIOS, for lifecycle controller, actually BMC. And right now it updates in bulk a few hosts. Let's see the host. So we can see downloading the firmware update. This is one of hosts that we are going to update right now. And seems like downloading the right package. Great. And the second one, just opened it. Let's see the job queue. And great. All the rest I suppose the same. Alright, let's see if it updates well and will be successful. Okay, so a few minutes later, let's check the status. And let's check the BIOS update that we did before. Okay, the results are here. Firmware update jobs successfully completed. All of them got a new firmware for iDRAC, and that's what we actually meant to do. And it also cleared some patch some BIOS settings for 3 hosts to append virtual CD. Alright, probably this wasn't really required, but okay. And let's check on the host. Yeah, we have this new firmware. Awesome, great. That's what this MCP actually capable of. To update BIOS iDRAC firmware version or actually any firmware for network cards or for anything else. You just need your files organized somewhere. Of course, you can do this via subscriptions and any system update and anything else, but in case you need to download files, you don't have subscriptions, you can do this easily with this MCP. And the only thing you need to download them from Dell because there is no any direct links for Dell. And right now I would like to try another changing things for management lab, it's reset to default. So let's start. I just dedicated a few hosts for this. Firstly, let's see which hosts from 10 to 18 have BIOS version 2. Alright, so we can see that all of them have BIOS 1. Let's update BIOS on 16, 18. Yeah, right. Update BIOS on a few hosts in bulk. It's also one of options. We can do this, of course, on 100 hosts if we need. Great. So we have this scheduled BIOS updates. In the restart, it will be updated. Let's see the host itself. Right now we have 166, and this should be updated soon. And a few minutes later, let's see, and we have 275 version of BIOS updated, and everything works. So these kinds of things that you can do with bare metal MCP, and not only. So right now I would like let's reset to default the BIOS on, let's say, host 16. I would not like to reset BIOS on all hosts. It will make my next week miserable. Still, there are things that you cannot do with Redfish, and still some human intervention may be required for different things, especially for BIOS configuration. Alright, so it will be restarted, and BIOS will be restored to factory settings when it's booted. And let's just check that it really restart the hosts. And we can see that the host is restarted. And we are going through, yeah, BIOS reset. So things that we tried to change in our lab management here, it's manipulating of iDRAC versions, BMC versions, updating them, resetting, updating of BIOS and reset to default, rebooting and management can power state of hosts, and more complex tasks like bringing them to compliance with requirements for specific software.